Hello students, welcome to lesson 6 on angle of elevation and depression. I hope you are all doing well. Good. In our previous lesson, we looked at example 5. We solved the question on example 5 and then I gave you an assignment. I hope you've all done the assignment. Good. Now in this lesson, we'll look at example 6, which is a little bit involving than example 5. Right. But before we begin, let's first look at the solution to the assignment. Right. So this was the question. Now, as I've been telling you, the first thing for you to do is to read the question to understand. You then visualize the scenario being described and then you draw a diagram using lines. I also told you that in order for you to draw the diagram, you have to use the definition of angle of elevation to help you identify the point of observation and the object. I hope that is what you did. Good. So now, you remember in example 5, I told you that there are two ways to solve such type of question. Okay, so I used the first approach to solve example 5. Now, I'm going to use the second approach to solve the assignment. So pay attention and follow me as I take you through the assignment, the solution to the assignment using the second approach. Right. So this is the diagram. This is the diagram. So BD is our cliff. And then A and then C are the boats. Now we're told that A and C are 30 meters apart. Okay. So that is why you see this 30 meters. And these are the angles of what? Of elevation. Good. Now to make our work simpler, we are using the letter H to represent what? The height of the cliff. Okay, so that is why you see H here. Now looking at the diagram also, you realize that the distance between AC, okay, is the same as what? The distance between AB plus that of what? BC. So in other words, when we add AB to BC, we are going to get what? AC. And we know that AC is what? 30 meters. You know that AC is what? 30 meters. So if you are using X to represent the distance between BC, then it means that the distance between AB is going to be what? 30 minus X. So that is why you see 30 minus X here, and then you see what? X here. Now looking at the diagram carefully also, you realize that it is two right angle triangles put together. That is right angle triangle ABD and that of what? BCD. Okay, good. So we have two right angle triangles put together. Now they also have the same perpendicular height, which is what? The cliff. They all have the same perpendicular height, okay, which is what? The height of the cliff. So what we do here is that we are going to find the height of the cliff based on the right angle triangle ABD, okay, and then we are also going to find the height of the cliff based on what? The triangle BCD. So that is what we are going to do. We are finding the height of the cliff based on triangle ABD and then the height of the cliff based on triangle BCD. Okay, so let's proceed. So from triangle ABD, tan 35 degrees will be equal to what? H on 30 minus X. So making H the subject, you are going to get 30 minus X tan 35 degrees. Expanding, you are going to get 30 tan 35 degrees minus X tan 35 degrees equals H. With the help of the calculator, you get tan 35 degrees to be what? 0.7002. So substituting and simplifying, you are going to get H to be equal to what? 21.006 minus 0.7002x. Good. So this is the height of the cliff based on what? Triangle ABD. Now we have to move on to find the height of the cliff based on triangle BCD. Right. So from triangle BCD, tan 45 degrees is equal to what? H on X. So making H the subject, you are going to get X tan 45 degrees. So tan 45 degrees is 1. So H will be equal to what? X times 1, which is what? X. I hope you are following. Good. So we now have the two heights of the cliff based on the two right angle triangles. Good. Now let's look at something here. Now if you look at this one, you realize that the h is in terms of x, okay? But we found that h is the same as what? X. We found that h is the same as what? X. So it means that in place of x, we can put what? H there. Okay, in place of x, we can put what? H there. So here we are going to substitute h in place of x so that we'll have what? The equation in terms of what? Only h. Okay, good. So that is why we have this. So h is equal to 21.006 minus 0.7002h. So we have replaced the x with what? With h. Good. So grouping like terms, we have this. Adding, we have this. Making h the subject, we have this. So simplifying, our h will be equal to what? 12.3550 meters. Good. But remember, we're told to leave our answer to 2 decimal places. So 12.3550 meters to 2 decimal places is going to give us 12.36 meters. So that is how come we have 12.36 meters here. Alright, so students, this is the solution to the assignment using the second approach. Good. But remember, we have to what? Conclude. So in conclusion, the height of the cliff is 12.36 meters. In conclusion, the height of the cliff is 12.36 meters. Right. So students, this is the second approach to solving the question. Now you compare it with the first approach, and the one that you are okay with, you go by it. Okay? Good. Now if you use the first approach, which I know that is what most of you use, you should get the same answer. So if you did not get the same answer, take your time and go through again and you'll be fine. Okay? Good. So that is for the assignment. Now let's move on to our main business for the day. Example 6. Right. So this is the question. Example 6. Now don't get scared by the mere seeing of what the question. Okay? As you see it plenty like that, it's no big deal. So you just follow the procedure that I've been giving you and you'll be okay. So as I've been telling you, the first thing is for you to read the question to understand. You then visualize the scenario being described and you draw a diagram using lines. So to help you draw the diagram, you have to use the definition of angle of elevation to identify what the point of observation and the object. Good. So we are going to follow the same procedure and we'll be able to solve this one. Okay? Right. So let's read the question to understand. The angle of elevation of the top of a tower from a point A on the same level ground as the foot of the tower is 30 degrees. From a point B, 20 meters away from A, and on the same side of the tower as A, and on the same level ground as the foot of the tower, the angle of elevation of the top of the tower is 60 degrees. Find I, the height of the tower to 2 decimal places. II, the distance between A and the foot of the tower to the nearest meter. Right. So this is the question. Now let's read it for the last time to enhance our understanding. The angle of elevation of the top of a tower from a point A on the same level ground as the foot of the tower is 30 degrees. From a point B, 20 meters away from A, and on the same side of the tower as A, and on the same level ground as the foot of the tower, the angle of elevation of the top of the tower is 60 degrees. Find the height of the tower to 2 decimal places and the distance between A and the foot of the tower to the nearest meter. Good. So now we've read the question, we've understood it, we have visualized it. It's left for us to draw the diagram using lines. But in order to draw the diagram, we have to use the definition of angle of elevation to fish out the point of observation and the object. Good. So let's get the key things out. Let's get the key things out from the question. Good. So it says the angle of elevation of the top. So here we've gotten what? Our object of the top. From a point A. So here this is our point of what? Observation. From a point what? A. On the same level ground as the foot of the tower. And here is what? The angle of elevation. So we have our object, we have our point of observation, we have the angle of elevation. Let's continue. From a point B, so here this is another point of observation. From a point B, 20 meters away from A, blah 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 blah. And this is what? The angle of elevation, 60 degrees. So here also it says what? The angle of elevation of the top. This is also an object. Okay, an object. So these are the key things we need in the question. So we've seen that we have 2 points of observation, that is A and B. 2 points of what? Observation, A and B. And then we have the same object, that is what? The top of the tower. The top of the tower. And then different what? Angles of elevation. So now that we have the key things, let's proceed to draw the diagram. Let's proceed to draw the diagram. Good. So we have a tower. This is our tower. And then we have a point A, which is what? On the same level ground as the foot of the tower. So this is it. And we're told that the angle of elevation of the top of the tower is what? 30 degrees. Good. So we are through with the first statement. Now, we're told that there is a point what? From a point what? B. Okay, 20 meters away from what? From A. And on the same side of the tower as what? As A. So once the B is on the same side as of the tower as A, it means that B will be what? Here. Okay, at this side. But we don't know the exact location of what? Of B. We know that it should be on the same side as of the tower as A, right? So A is here, so it means that B will be somewhere here. And we also know that it should be 20 meters away from what? From A. But we don't know whether it should be in front of A or what? Or behind A. Okay? 20 meters away from A can be in front of A or what? Or behind A. So how are you going to know the exact location of what? Of B. So that is where we have to pay attention. Okay? Good. Now to know that, what will help us do that is the angle of elevation, the value of the angle of elevation concerning that of what? Of B. Now we're giving it to be what? 60 degrees. Okay, 60 degrees. So 30 and 60, which one is bigger? Definitely it's what? 60 degrees. Good. Now in a right angle triangle, okay, the biggest angle there is what? 90 degrees. So any other bigger angle compared to a smaller angle, okay, should approach what? The 90 degrees. Or should be closer to what? To the 90 degrees than what? Than the smaller one. Because the biggest is 90. So the next bigger value will be what? Should be closer to what? To 90. So comparing 30 and 60 degrees, 60 is bigger than 30. So it means that 60 degrees should be closer to 90 than what? Than 30. I hope you get it. Good. So once 60 should be closer to 90 than 30, it means that B will be what? In front of what? A, and not what? Behind A. Okay, so let's get our B. So this is our B, and it is 20 meters away from what? From A. And the angle of elevation was given as what? As 60 degrees. I hope you are following. Good. So now, let's complete the labeling. So this will be our C, and this will be our D. Right. So let's finish it up. Good. So make sure, don't forget your 90-degree angle. Always let it count. Okay. That is very, very important. Good. Now to make our work simpler, we are going to use H to represent the height of what? Of the tower. Okay. So we are not going to use CD. We are using H. And also the distance between CD were not given, so we are using X to represent it. I hope you are following. Good, good, good. Right. Now looking at the diagram again, we realize that it is two right angle triangles put together. It is two right angle triangles put together. Right angle triangle ACD and then right angle triangle BCD. So two right angle triangles are put together. And looking at the diagram also, they all have the same perpendicular height, which is CD. So the perpendicular height for triangle BCD is what? CD. And then the perpendicular height for triangle what? ACD is what? Is CD. So they all have the same what? Perpendicular height. So what we are going to do here is that we are going to find the height of the tower based on the two right angle triangles. Okay, so we'll find the height of the tower based on triangle BCD first, and then we'll find the height of the tower based on triangle ACD second. Okay, then we'll be getting two equations. Okay, but all in terms of what? H and X. Okay, so let's proceed. Let's proceed quickly. Good. So from triangle BCD, okay, from triangle BCD, the appropriate trig ratio we use here is tan. So tan 60 degrees will be equal to H on what? On X. So X tan 60 degrees will be equal to what? H. We are making H the surface. Good. So with the help of the calculator, let's find the value of what? Tan 60. Good. So tan 60 degrees. Right. So we have root 3, but I want it in decimal. So we have to press this button. Okay, good. So now we always have to approximate to 4 decimal places. Okay, so it's going to be 1.7321 because of the 5 here. Good. So tan 60 will be giving us 1.7321. Right. So let's proceed. So it means that we are going to have our H to be equal to 1.7321x. 1.7321x. Good. So we have our H in terms of x from what? Triangle BCD. Now we have to find our H in terms of x from triangle ACD as well. Okay, so looking at it, the opposite will be the same, which is H, but the adjacent will be what? 20 plus what? Plus x, because the adjacent is what? AC. So it's going to be 20 plus what? Plus x. So let's proceed, and our angle will be 30. So from triangle ACD, okay, tan 30 degrees will be equal to H on 20 plus x. Okay, so making H the survey, we are going to get 20 plus x into brackets tan 30 degrees to be equal to what? H. So expanding, we are going to have 20 tan 30 degrees plus what? X tan what? Tan 30 degrees to be equal to what? H. I hope you are following. Good. To be equal to 8. So here also we'll need the calculator to find the value of what? Tan 30. Right. Good. So let's find tan 30. Good. So we are getting root 3 on 3, but we need it in decimal. So we press that function, the button. So we have 0.5774. Okay, we are approximating to 4 decimal places. So we are having 0.5774, but we have to multiply it by what? By 20. Okay, we have to multiply it by 20. So let's multiply it by 20. So times 20. Good. So we press this button. Good. So we are getting 11.5470. 11.5470. 11.5470. So let's write it down. 11.5470. So we are going to have 11.5470 plus, let's find the tan 30 again. Okay, we had 0.55 something. Let's look at it. All right. So tan 30. So 0.5774. 0.5774. 0.5774. 0.577 x equals h. I hope you are following. Good. So this is what we have. This is what we have. So let's write this. So h will be equal to 11.5470, okay, plus 0.5774 x. Good. So we now have our h to be 11.5470 plus 0.5774 x. Good. So we have gotten our two heights. That is one from triangle BCD and then one from triangle ACD. Now at this point, there are two ways to go about it. You can either find the value of x and then you use the value of x to find the h, or you can find the value of h straight away. Okay, but it will be easier for us to first find the value of x before we use it to find the value of h, because here we have h to be 1.7321x, okay, and then here also we have our h here, so we can substitute the h in the first one, which is this one, in place of what, the h here, so that we'll have this equation for it to be in terms of only x. Okay, so we can let this one be in terms of only x by substituting the value of h in this first equation here. Okay, so that one will make our work easier. It will be linear. Okay, so let's use that one. Okay, all right, so it means that we are now going to have 1.7321x, okay, to be equal to 11.5470 plus 0.5774x. Good. So we have substituted the h here. So now, grouping like terms, we are going to have 1.7321x plus 0.5774x to be equal to 11.5470. I hope you are following. Good. So we now add these two. So adding, we are going to have 2.3095x. So you can use your calculator to verify, to be equal to 11.5470. Right, so making x the subject, x will be equal to 11.5470 all on 2.3095. Okay, so with the help of the calculator, let's see what we'll have with the help of the calculator. Good. So we have 11.5470, okay, divided by 2.3095. Good. So let's see what we'll get. Right. So we are getting 4.99978. So to 4 decimal places, we are going to have 4.9998. 4.9998. Right. So let's proceed. So our x is going to be 4.9998 meters. 4.9998 meters. Good. So we have our x. but we are to look for what? H. We are to look for H. So remember, in the first equation, our H is equal to what? 1.7321x. So now we are going to substitute the x that we've gotten here, so that we'll get the value of what? Of H. Good. So our H, which is what? 1.7321x, will now be, H will be equal to 1.7321 into brackets 4.9998. So our H will be equal to, let's check it with our calculator. So we now have 1.7321 times 4.9998. Okay, good. So let's see what we have. Good. So we are going to have 8.6602 because we are approximating to 4 decimal places. So 8.6602. 8.6602. So our H is going to be 8.6602 meters. 8.602 meters. But we were told to leave our answer to 2 decimal places. We were told to leave our answer to 2 decimal places. Therefore, our H will be equal to what? 8.66 meters. 8.66 meters. So students, this is the answer to the I. We are not done. We have to look for what? II. So let's conclude. Therefore, the height of the tower, is 8.66 meters. Therefore, the height of the tower is 8.66 meters. Good. So now let's look at the II. The II. Now the II were to look for, let's see the question. So II, we are to look for the distance between A and the foot of the tower. The distance between A and the foot of the tower. So this distance. So looking at the diagram, you realize that it's going to be what? The 20 plus what? Plus x. The 20 plus what? X, which is what? AB plus what? BC. So let's proceed. So it means that from the diagram, AC will be equal to AB plus what? BC. Okay. So AC will be equal to AB plus BC. Now substituting, the AB was giving us what? 20 plus, and the BC is the X, and we calculated it to be what? 4.9998. So now our AC will be equal to this plus this will give us what? 24.9998 meters. 24.9998 meters. But remember, we're told to find it to the nearest meter. To the nearest meter. So 24.9998 meters to the nearest meter will give us what? Will give us 25. Will give us 25. Good. Will give us 25. So that is the distance between A and the foot of the tower, is 25 meters. So let's conclude. Therefore, the distance between A and the foot of the tower is 25 meters. Is 25 meters. So students, this is the solution to the II. This is the solution to the II. So we are done with example 6. we are done with example 6. So take your time, go through it again, and then you'll be okay. Right. So this is where we'll end this lesson today. Now, you know I will not leave you without an assignment. Good. So let's look at the assignment. Right. So take this assignment and then solve it for me. The next time we meet, we'll look at it. Okay? Right. So, till we meet again. Bye.